Hello, welcome back to Math with Patrick. Today is February 8th, and we got the 39th problem from this Daily Epsilon calendar to solve. Let's try it together. Okay, in a previous video, I was forgetful a little bit. I forgot whether or not 0 was considered a natural number. Here, I'm going to say 1 is my first natural number, and then we start counting up by all the whole numbers. I mean, I've seen in other places that 0 is considered a natural number, but I think all mathematicians can agree on these all definitely being whole numbers. And then so we should probably, if we're going to call it a new set of numbers, the natural numbers should probably just start at 1 and then count up from there. Okay, so we got two natural numbers, A and B. Oh, okay, yeah, and they're both greater than 1, so let me knock off 1 from that list. And apparently, a to the b plus b to the a is 100. Okay. And I'm trying to find the sum of these numbers. And that's going to be today's date, 8. Okay. So, wow, I have a lot of numbers to choose from because I have any natural number that's bigger than 1. So 2, 3, 4, 5, 6, 7, 8. I mean, eventually it doesn't really make sense to have like 10 doesn't already make sense. Because say I pick my smallest number as my base, 2 to the power of 10, that's already a giant number. I think this is 1024, and that is way over 100. So it doesn't even matter that I'm going to also add on a 10 to the power of 2 onto this. That's already way too big. So there's no way that 10 is going to be a natural number for me to use. And I mean, I could just keep counting down until I finally get a number that is below 100. So maybe let's count up. That makes a bit more sense. 2 to the power of 1 is 2. That's 4. I'll just count my fingers. 8, 16, 32, 64, and then 128. So it doesn't make sense to go as far as 7. And maybe I'll even write that out here. I'll just cross off 7 and above, because if I pick my lowest base 2 and raise it to the 7th, that was 128, and then I'm already way too big. There's no way that I could decrease it to 100. Like, I don't think I could get a negative number out of a base to an exponent. Well, okay, I ruled out possibilities for my numbers. Essentially, I just have 5 to choose from. And I maybe I already have the answer. Is it 2 to the 6 plus 6 squared? Yeah, because I just said 2 to the 6th is 64. And then 6 squared is 36. And so adding these together, I get 100. Cool. Well, A and B must be 2 or 6, and I do have some flexibility where I could switch them in either spot. So maybe A is 2 and B is 6, or vice versa. A is 6 and B is 2. But either way, when I add 2 and 6, I get 8. And that is today's date. Well, great. We're all done, I guess. Maybe let's do a little bit of exploration just to make sure that that was the only potential solution. So let's see, I could also create a function with 2 input variables, and I'll do x to the y plus y to the x. Actually, you know what? Let me do a's and b's, just so Desmos will ask me for some sliders. And then I can restrict them with that range that I found earlier from just 2 to 6. Because, any lower, and then I'm not even solving the problem, because it said that these natural numbers have to be greater than 1, and any bigger, I'm going to go over 100 every time. So, okay, here are my sliders. Oh, and I guess I could put the step of 1. That way I'm just looking at integers. And let me change my input variables to A and B so they match. And I guess I don't even really need to make it a function. There we go. Okay, so now I have some potential values. So if I restrict A to B2 and B to B2, then yeah, this makes sense that 2 squared plus 2 squared, that's 4 plus 4, that's 8. And so if I just try incrementing B to 3, there we go, or 4 or 5 or 6. Oh, well, there's our answer. So 2 and 6 is a possible solution, but none of the other ones worked because they're all too small. Then if I try a is equal to 3, then I was thinking about like the parity of it, or like the odd or evenness, where this one is definitely going to be odd every time because it's 3 to the power, or it's a power of 3, so it's always going to be odd. So let's see, b would also need to, or b to the a would also need to be an odd number to get 100. So I would need another odd base here. So it doesn't even make sense to check b equals 2 because I get an odd number here. So b equals 3 doesn't work. B equals 4 doesn't work because it's odd, and then it's also above 100 already. So for many reasons, I don't even need to check 5 and 6. 6 because it's too big, and even, and then I guess I should have checked 5 based on the fact that it would have produced an even answer, but it's already too big. It's over 100. So when a is 3, none of these work. I could check a is 4 and just kind of going through the values. 2 is too small, and then 3 is too big. Checking 6. 2 is too small. 3 is too big. Sorry, did I say checking 6? I meant 5, when a is 5. And then finally, when a is 6, cool, I get another 100. And then all of these values are now way too big. So just kind of inspecting the sliders here, the only time it works is a 2 and a 6 or a 6 and a 2. Lastly, I just wanted to share the whole graph. It kind of looks like just like the 1 over x function, although it is missing the other arm here. And what did you hear that? That was Quill. Here, I'll bring him up. I guess I would need to kind of scale it up a little bit so it would match, but it doesn't really line up, so never mind. And also, something I noticed is that if I do like 99 to the power of 1 plus 1 to the power of 99, I do get a 100. So this curve does intersect one more whole number point, or I guess two more, because it's 99 comma 1 is right here. And then if I went on the other side, it would have been 1 comma 99. And both of those actually do return a 100, and they both are natural numbers. They just didn't satisfy the requirements of the question for today. And one more curious thing about this function is instead of like trying to hit 100, what if I try to hit like any other number? Let's see. Well, zooming out, I don't really see anything right now. And then if I go in the negative direction, it also doesn't really show up. So I think my numbers need to be bigger than 1. And then once they're bigger than 1, ooh, do you see that at the origin? I get this like really neat shape coming out here. And there's like two different curves, and at a certain value here, they kind of like link up and then disconnect. It's like what, between 1.3 and 1.4. So I don't know. One curiosity of mine is like, what is this value that like just perfectly links them up right here? And I don't know. How would I be able to find that? So I guess that's what I'm going to try to figure out on my own. And maybe you could try that on your own too. But just something kind of neat going on with this x to the y plus y to the x. So anyways, we already figured out the solution today. It's 2 plus 6. It's 8. Hooray, that's today's date. Isn't that great? But I don't know. Just some other curiosities with that exponent setup we had. So anyways, hope you enjoyed the video. I'll see you tomorrow. Bye.